I just want to summarize that from the supporters of this workshop, the goal is to try and get an open standard that meets the needs of DoD specifically, and other users who are going to not want to. I guess it's unclear from my side if paying is a problem or if it just if open is the requirement, completely open and non-paying. Go ahead.
So I think we need clarification by what you mean by open. Because when you use the term open, I think of it as meaning that there's no restrictions on who can contribute. For instance, I think what your requirement or the requirement from the Air Force is that it's royalty free.
I think that is correct, but you're right. I need to get some clarification on that. And by the way, Steve, can you bring up the extra microphones? We have a bunch of extra microphones for you to use here too. Yeah. So that's.
I'm pretty sure that Dr. Hopper
That's what I would suspect.
Potentially, he doesn't want that and doesn't know it. I think that's what he thinks.
Yeah. Yeah, I think it's not on. Yeah, leave that there because I want the audience to. Testing. That's working. Okay, so if we assume it's royalty free, they specifically said, Darrell Hopper specifically said SMPTE standards don't work for them.
They said SMPTE capable?
Yes.
So we require RAND statements with it, which doesn't mean it is exactly license-free, but it's reasonably non-discriminatory. So maybe that's what they're talking about as not open in the case of that.
Because that could involve transfer of money.
Right. So, and to be clear, a lot of our standards are royalty-free. But there are some standards that do have RAND licensing terms that go along with them, and then it's up to the company. SMPTE doesn't get in the middle of that. We're not allowed to do that. It's really up to the individual companies to state how much they charge for the licensing of it. But it needs to be reasonable and non-discriminatory.
Okay.
Yeah, I think if they truly are looking at truly royalty-free, then they are not going to get the best solution out of this. They're going to go to things like, like compression, X264, open source, that kind of stuff is nowhere near as good as some of the latest advances in compression, and the same will be applied across the board. So they're really going to have to choose if they want the best performance, and it looks like they do from what I've seen on the simulations. Then they're going to have to pay for it.
Well, it's easy to say. I'm not sure that may be a policy issue that's dictating that. Okay. Are there recommendations or steps that can move toward open standards, or are there ways to do a workaround here?
So, we created our first proprietary codec. One of the first things we did with it was we wanted to get it running in the browser, and we were thinking, well, we all the browser to adopt codec. We essentially built a JavaScript decoder, which ran in every browser, and ran in IPC, so it was on the decoder for the browsers. And I started to think that, the only way we do that is because the GPU is added to the web. And if you take that to its logical conclusion, when you have some sort of web-based browser that can touch every part of the device, including the GPU, on all of our codecs, they run faster on a GPU than they do on. In some cases, the basic it is, it's going to take a while to get out there. So, being able to build into whatever spec comes out, the ability to bootstrap new codecs, new devices, new techniques is really important. And in the OS player, it's all really good. Really good used by Google and Facebook for learning. It wraps a scripting language around every single native API. So you can just send out scripts that can actually build an application similar to that JavaScript. And if that were part of the spec, then you can do anything you want as part of the screen, as part of the content. So it's really compelling to sort of take that. That is definitely a workaround that we're investigating to distribute anything that we want to put out there in something as open as web.
Those lights are highly directional, not on the curve. So if you don't
Sorry.
it's very different if you get enough camera. Scary.
A question I would have on this is, are you talking about really open source, which is a different thing than an open standard? So we really have to clarify what we're talking about is when they ask about open standard. Because if I think about open source, sometimes it's a moving target. Yes, it's free, it's clear royalty, all that kind of stuff, but which version of the open source are you working on? So that can be complication as well, too.
Okay, thank you. I'll try and look for that clarification.
Please repeat the last, what was the, still want to do the open web?
So I was discussing a workaround that we had implemented years ago to get our proprietary codec, which we'd use for adaptive streaming, into browsers. And after failing to get any browser companies to add it, we built a JavaScript version that was using the WebGL, which is the GPU shading language that is exposed to the browser, to do all the decoding. And since that time, we've actually been able to build high-speed encoders for light field for everything that we want to do in OpenGL Compute. And if we have to, even in pixel shaders. So that's one way that you can get around having just the smallest possible sandbox to be able to deliver something totally new in a browser.
I'm sorry, it's still not clear to me. What of your stuff is still proprietary and what isn't?
The codec pieces are closed source. We compile to JavaScript, which means it could run anywhere, which means that it is, the JavaScript code is no different than the text on the web page. We're considering opening up the codec to JPEG Plano and that, the MPEG as well. The rest of what we do, the data that we touch, is designed to be open. We want open standards from all the different content applications to the devices. Some of the computationally intensive things that we do, such as encoding and decoding, even for us, we kind of want to be able to support that and make that a living codec that can run on top of a GPU. So nevertheless, when people are depending on it for mission-critical elements, putting the source code out there would probably be helpful and can even lead to other innovations. So that's our roadmap.
Only one comment. I mean, it's clear that in all standardization organizations, means JPEG, MPEG, and SMPTE, there is not necessarily a royalty-free fee involved in it. And sometimes it's difficult to reach this agreement, and you can never know this, but in most of the MPEG and JPEG activities, it's the intention, of course, to have some royalties afterwards. That's the reason why the companies are coming together and working on this topic. And otherwise you would be more or less alone, because what is the intention to be there?
Yeah, no, I hear you and I understand, and it's fair and reasonable. It's just there's a particular constraint. That's all. Tommy.
I think that the driver might be that at the moment the Air Force is sponsoring a considerable amount of the actual 3D displays that are being developed. I'm trying to think of the light field displays that are being developed. I'm trying to think of a light field display being developed that is not sponsored by DoD, and nothing comes to mind at the moment. Now, I'm sure that will change, but so the worry may be that typically when you buy equipment or when you buy software, the company that you bought the equipment from or the company that you bought the software from paid the royalty. But now, in this case, the Air Force is building the equipment, and so they're worried about having to deal with all the intricacies of going to the licensing and royalty bodies. That may be what's driving that initially. I mean, longer term, it may be that they buy equipment that's already licensed and royalties paid.
Okay.
And I think in this specific case, it quite depends how the workflow is looked like. So I think maybe that's also an important question. So what should be a let's say, royalty-free fee standard. So for me, an open standard is also what has royalties in it. So is it, let's say, a data representation format? Is it encoding, decoding? Is it maybe the specific processing to go from one modality to another modality? And especially for all of these light field approaches, there is much more, let's say, a workflow involved in this transition. And we have to keep this in mind, and this is a reason why I think there is also a lot of research necessary on this topic.
Yeah. Yeah, and honestly, I'm not sure exactly where the sensitivities are in terms of royalty payments and where they are, as you point out, in the workflow. So I think this is kind of an evolving thing as the process will evolve. But that certainly is their starting point here, is to try and get something that doesn't carry royalty.
It looks like it may be difficult.
Indeed.
If I might ask on that point, since you bring up the government sponsoring the research, I think the attitude might be that the taxpayer and the consumer is already funding this research and essentially are the owners. And it would not behoove the government to let someone else make an exclusive monopoly of it by making it proprietary. And again, coming from the 3D side, where we spent decades building up a momentum, where there was an audience that was hungry for it, and the industry had come out of a long phase where they thought of everything as being small niches that they were having to control, and not that you had a market that was so voracious that everything you fed them would make them hungrier. And the 3D market would have been really booming if we realized that 2% of what was available was more than you could handle. And an open source environment would benefit everybody. So then Sony and the others started making their exclusive proprietary equipment that required you to dispose of everything you had, including all the audio files that were long built-up stereo systems. And you literally had the audience scared away, and Sony virtually going bankrupt. And our industry with it. So that is, I think, what you have to look for with VR. This is also another one where there's blood in the water and the sharks will go crazy for it, but not if you go around killing the sharks before they get to it. So all you have to do is say to yourself, if everybody buys into this, can I handle that much as 2% of that market? Rather than trying to control 100% of the market, which is far beyond your ability. So how would we be addressing that? How can we maintain that? Maybe it would require that the government itself controls the standard.
Well, that may be a non-starter, but nice try.
Control the standard. You can have the lawyers control the standard. I'm going to say the argument against open source GPL. It's a choice between open source GPL and open standard. For government work, you must have the open standard and not the open source GPL, because the open source GPL effectively taints everyone who touches on it, and they cannot, in any easy way, without severe clean room firewalling, work on anything secret. No. Unless you want to give your soul away to the lawyers, you really do want an open standard, not an open source GPL, unless you happen to be a company that is so huge that you have other side businesses and no one would dare compete with you anyway. That's one.
Okay. Okay. Yep.
Here's a suggestion too, that there's precedent for successful non-royalty bearing standards like OpenXR, like PPI. I mean, those could be involved. And it's not just GPL or proprietary, you have the STMIT patch license.
Yeah. Okay.
And
Good point.
On that point, how come VP9 is such a small part of the market versus H.264?
Yeah, I think it's a little bad to brand SMPTE as not having royalty-free standards. We have plenty of those. So there is a big difference between RAND, and then royalty-free.
Yeah.
And so just that's a big distinction to keep in track of.
Okay. All right, I think we've driven that into the ground. Tommy also put up this workflow, which you guys can't see, kind of a generalized workflow. Just to remind you, if you can crane your necks for just 1 second. 3D source application leading to some kind of a source API, which generates a 3D frame plus metadata, which gets encoded, sent out to the network, decoded, where it then reconstructs the 3D frame, and then a display API does the magic to turn it into whatever display technology is needed to create the image. So I had a question about this. Should actually didn't you put these questions up in your presentation? I did. Maybe I shouldn't have. Yeah, I think you did, didn't you? Should the source application be forced to create a common 3D format? But I guess you put it out there, but no one really responded.
Well, that's these are questions.
Yeah.
And it's a great question. I mean, the entire point of my presentation was
Mike.
The entire point of my presentation was solving that problem. And so when you look at, you can't force every single vendor to export a format, at least not in this early stage. So from our perspective, we put out 21 plugins that all have the same renderer and the same import and exporter. And what they export is an open container, zip file basically, with OpenEXR for textures, GLTF for meshes, and Alembic. Everything that you need in that scene file is there. The last piece was Open Shader Language, which was from Sony, and that is in there. And you can also import that into other workflows. So we use that interchange format because Autodesk didn't build it. No one ended up building it. Pieces of it are out there. So Orbex is just like validating the different ones that we actually were practically able to connect. And we do now have 21 plus applications that export into that format. And that is just for rendering the 3D scene. When you output it, then the data is even simpler. It's just JavaScript or LLVM and shaders that can be consumed in a browser. And then we have had great participation from Oculus, from Samsung, and others to actually support the metadata that is outputted from the rendering pipeline. So it's definitely something we've been trying to solve, which is why we want to contribute the Orbex scene and metadata spec to JPEG, Plano, and MPEG, so that those can be added to the toolchain.
It sounds compelling. What's the downside? Where are the problems?
None that, I mean, other than us needing to make money by selling the renderer, which is our business, I don't want to own users' data. I think that, in fact, having an open spec for that makes people more comfortable with our tool set. But I don't think there's really a downside. I just think that we were expecting others to do it in the last few years, and it just never happened. And we saw pieces of that. And what we've found is that we've actually joined groups like Kronos to help with GLTF, because GLTF is this great mesh format that is very compact. It's like a JPEG for 3D models. It's way faster than FBX. It does bone and skin animation. And with our help, we want to get it so that it can replace Alembic and OBJ, and you'll just have one mesh format. And it looks like the browsers are all going to build it into the browsers themselves. And Orbex just wraps around that. I mean, it's basically, Orbex is like a QuickTime file, which ended up being used for MP4. We want to have those blessed formats that we think are really good, mixed with things like Open Shader Language. There's a lot of other things that are missing, but all of that in an Orbex scene that isn't open source is just XML data that anyone can parse. So that's what we want to contribute. And what's cool is that in practical use today, we have every single application that people use exporting and importing this format. So why not turn that into a spec? There's no reason not to do that. No downside.
Now, how difficult would it be to go to a hardware implementation instead of well, I'm thinking you're not going to run a web browser on your 3D display. Maybe you are. And,
well, yeah, WebVR. Like WebVR can do a full VR experience, and Facebook and Google and others are backing it.
But the 3D display nominally, our 3D display is not running a browser. I'm just wondering. I'm wondering.
It's running some sort of stack, right? Some sort of software that defines what the.
There's a. Go ahead, Steve.
Microphone.
To be clear, again, terminology is the most important thing. When you talk about the display, you're talking about stereoscopic 3D, versus here you're talking about API for a 3D model. Like, okay.
It's a multi-view auto promissory style.
Light field display.
So, well, excited for the. Okay, we're going to go yeah, that's a lot of. No, is important. It's one of the things.
It's not a planoptic light field display, but it is a light field display. It creates a light field. Yes.
Right, with no hidden.
Right, so we call that auto-stereoscopic.
Well, the light passes through the actual 3D point, and your eyes point and focus on that 3D point. So to us, that's a light field display.
Well,
Well, the light is actually, it's got direction, it's got luminance, it's got X, Y, Z.
It's one example, one example of an auto-stereoscopic display. That's what it is.
If you go to the Hollywood community, it's auto-stereoscopic.
As opposed to light field.
Yeah. So, in other words, you got to talk in your language, not in math.
Yeah.
there you go.
One
Yeah.
of you is stage right, stage left, not yeah.
Yeah.
Okay.
Steve.
So the point that I want to make is that we do have a version of our software that will run with Firefox. We have Firefox. We do the medical data that shows the scene. And that does in fact run the ground. It's just not Firefox. So we can take browser data and display it in 3D. It's coming out like a WebGL.
And by the way, I mean, I have a lot of thoughts on WebGL and the limitations of the browser-based approach. And the reason why we have Orbex Media Player as an even simpler app is that you can take the open source Luigit, which is 200K, wrap around, Vulkan, things that are just not even in WebGL, and you can do anything with that. I mean, we have basically a single script file that bootstraps our entire viewer on any device, and it could be, for a specific display. And, I've been waiting again for the web browser vendors to go to support compute shaders in OpenGL. They're not doing it. Vulkan is like a ways out. They'll get there, but in the meantime, we found Luigit was a great way of just getting the equivalent of benefits of a browser with all the pieces that you want to do to touch native code, native sensors, and it is, it's pretty robust. So that's our secondary approach besides the browser.
Well, so let me ask a corollary question. What data sets do you think this approach does not work for? Does it work for MRI slice data, CAD data, SAR data? For you, Jules, yes.
Yeah, no, I think it can work for anything. I mean, we everything that I just showed, including our renderer, we could build a version that could run a Lua script, tap into Vulkan, even use WebAssembly, which is now having threads and SMPTE. So you have the equivalent ability to build almost a native performance app with all the capabilities of a closed platform, and that's what we're pushing for. So when we get somebody like Samsung or Oculus or others we haven't announced yet to help push Luigit as a framework that is even more powerful than the web-based approach, there's nothing that you can't do. There's nothing you can't write in OpenGL compute shaders or Vulkan, including codecs, including ray tracers. Everything that we've done is on the GPU, and all of the GPU code can be run even on mobile chips now. With Vulkan, you have everything that matches desktop performance and APIs. So it's pretty compelling as a platform for everything, I think.
Okay.
Typical light WebGL. One of the things that's happening with a browser today is you assume sRGB, you assume 8-bit color, all that stuff is just sort of default. We're going into a world now where we're talking high dynamic range, we're talking EQ encoding possibly, we're talking different color spaces, D3 color space, 2020 color space. From the point of view of distribution of HDR, we're talking about metadata at a frame-by-frame basis. Is all of that stuff being considered in what you guys are doing?
Absolutely. In fact, we built an OpenGL ES compute shader that runs on every mobile device that is able to pull down FP32 spectral data. So it's not just RGB. It can be multiple, 8 frequencies of light, which is what our renderer does. It's a spectrally correct renderer. And the artists inside of the 21 plugins can define the LUT. They can define all the post-processing effects. And they can do that even for different color spaces, for 709, for 2020. And then ultimately, if you want to do something that is defined for a specific device, you can do that in the pixel shaders that can do the tone mapping on the client. And that's really important when you're doing compositing of light fills client side. You have to do it in linear space. You have to have at least FP16, FP32 is, is doable. And all of that is really easy to encode and decode in GPU shaders, even on a phone. 32-bit.
You have to have 14-bit. That's some.
It's sort of last century.
Yeah. So the reason why
10-bit will not do it. You need at least 12.
you need at least 12 to do Rec 2020, and also if you're doing things like depth information or normals or things that are really precise, you need to go at least to 14 bits for depth. And
Well, I mean, for that stuff, you need half float.
FP16 is pretty good, yeah. And there are certain cases where
10-bit does not cut it.
no, I agree. So that's why we have shaders that can decode all the way up to 32-bit per channel, and that works. And we also have a half-float version and an FP32 version, which we did for Autodesk, so they can use their range scanners with this codec.
So for me, a key question is, and it's the same for the broadcast industry, as we go higher frame rates and we go higher bit depths, etc., the bandwidth goes up. Okay, then H.266 is going to be coming sometime in the next 8 years, but what does it mean? Does it mean that we have a great system, a great solution that can't be distributed because the actual bandwidth isn't available in CDNs and in last mile?
I have a lot of thoughts on live streaming, and there is definitely going to be a big shift when you have the metaverse, which is where VR and AR is heading, where you have persistent worlds, where you have a portal into that world, and that's where Facebook is building that with Oculus Social, with the social layers, and in order for that to work, you're going to have a live adaptive stream. You can't really cache. It's not about caching a light-filled movie at that point. You're going to have to basically look into a cloud rendered stream, and the adaptive streams already work really well. What we're showing there was already running over LTE so that it can run on a phone. So if you have viewport adaptive streaming, that's going to help solve some of those problems. If you want to have the content be downloaded and cached, well then, yes, you're going to get all those problems solved. I also think that when it comes to motion, what we've discovered with our light field codecs is that it's not just about X, Y, and Z. It's also the fact that if you have motion vectors, which we know from the entire clip that we're rendering synthetically, we can store that. It's not like the traditional video encoding, and that's the power of being able to have a synthetic pipeline touch all the data that before it even gets sent into a media stream. And ultimately, you need that if you're ever going to have the ability to change and render that live. The delta between a Photoshop layered source file and a JPEG, those things will blend together when you want to be able to make those changes live and not have that separation of the media and the source format, in my opinion.
Well, where does the Dolby system fit into this? James Cameron keeps talking about that's going to give the metadata that tells us what the 3D is supposed to look like. It tells that to your set so that it delivers it. And how much of this high tech is going to be making it exclusive so that the majority of our audience cannot afford to take part in it? And what are we going to do to open it up to the majority of the audience that is, let's face it, not able to afford all the upgrades that we have nowadays in our modern economy?
Well,
Yeah, exactly.
if I can answer your...
Yeah, how come you're not up here, Walt? Oh.
So, in general, most of the upgrades, they come as upgrades over time. You try to go out and just really revolutionize something, tyranny of small decisions or tyranny of small choices. And so coming out with a $20,000 system that does everything, everything is implemented. And many of our models, we get Dolby, many of our models are based on that. They're based on incremental change in order to effectively roll out an entire ecosystem. For us, we focus on ecosystem. That's what drives it.
Yeah, and I think that's a healthy philosophy, and you've done a great job of driving the discussion in ecosystem development in HDR and wide color gamut, and I'm not sure I've seen that company yet that's going to drive it in light, well, certainly not in light fields, and I'm not sure about VR yet.
So
Yeah,
Too many people are trying to attack their favorite part.
yeah, yeah.
Nobody looking at the entire ecosystem.
Well, exactly, exactly.
It's largely, this is me personally, I like competition. For me, it's a lot of salt.
Yeah,
That's going to cause failure. That's how that's the reason.
yeah, yeah.
That's why the study that we are industry for, exactly the reason. Counting.
So actually, let's move on to this idea of what the VR Industry Forum is doing and what a potential consortium from.
Did we answer this question?
Oh, I don't know. Did we?
Just curious, I wasn't sure.
It's a tyranny of small discussion.
Yeah, the winding path, any number of things. I wasn't sure if we covered the answer.
Probably not.
Yeah, okay.
Probably not.
Decision.
Let's move on. I don't want to, let's move on a little bit.
I do have 3 letters that will be a nice sort of, who wrote you? DDX. There we go.
Okay.
Really? Not open.
Says open.
Right.
Yeah.
It suffers from the same problem that DDX does.
And to be clear, in the 3D question, you're talking about, I mean, we do have a 3D framework, or you're talking about a 3D model.
Talking about light.
Yeah, so we should probably take light field instead of 3D.
Well, you already told me my display wasn't.
I may be mistaken, I don't know, I haven't figured.
Well, clearly, we need a lexicon for light field and advanced imaging and display technologies.
Just check with our, she doesn't have it covered.
We have it, and maybe not to everybody's satisfaction, but
You're working it.
Thing number 1, give it a name.
I'm just happy, I'm happy I now have a bevel tomorrow. I think John has something to say.
I'm just trying to figure out, are we talking about the rendering of vector data? Are we talking about raster data? Are we talking about content creation? Are we talking about, I mean, what are we, not in this question because that's a new question, but everything I'm hearing isn't taking into account the display specific process, the content creation aspect. It sounds like it's all about rendering of vector data, which is great. So I guess I just wasn't clear on the terminology either of, is it 3D geometry 3D, vector 3D?
Well, I think that's what he's talking about. Yes, I think that's one proposal.
Well, okay, if that's being the case, then is that actually appropriate for any standard if it's not incorporating how you actually generate all of the content? So it's how do we incorporate everything end to end? It's not a judgment, it's just a kind of more of that open-ended question of how do we actually create a standard format that is consistent across how you would capture the content, selfishly, of course, how you would render the content. We've had to address that in our workflow because we have to integrate the CG world with the live action world. We have to make sure that you can composite, you can do the visual effects. We have to get to all these questions about what is the bit depth, what is the actual dynamic range that you can achieve from it. We are working towards, in our format, it is open because it's EXR, where everything is in fact layered. I can store vector data inside of an EXR file. I can store all the geometric information. I can store the point clouds. I can do all of that, and that's my interchange format between everything. And then that is open at that point.
Yeah, and the thing is, EXR is something that, again, we use that as our default as well in the Orbex. Orbex is like a container file, and when there are things missing from the EXR spec, like they don't do stereo Q maps correctly, so we have an XML or JSON extension that supports that. Same thing with the Alembic files; they don't have panoramic cameras. So there's a lot of good stuff already in EXR, but you're right. I mean, that covers a lot of what we'd want to do in terms of storage. It is deep pixel information. They now have masking in there, so it's great. Similarly, when you're talking about a point cloud coming from of particles like OpenVDB, also in Orbex, and for BRDS, Open Shader Language, and for mesh data, which is something we struggled with again with Alembic because it was too heavy. GLTF is great. I mean, those are the pieces that will give you the scene data, and then anything that doesn't fit into that box is
an OpenGL shader or open shader language, volume that you can then procedurally generate, which you want to have anyway. So all of those things are what we've thrown into the bucket of ORBEX. All of these things are already open, and the things that are missing are just small little corrections we've added in metadata. But, that's, I think we're all on the same page as how we, it's important to get the editing and scene data to be at the highest possible quality, and then create multiple outputs of that can then be adopted in different ways. But I think the source information during the editing and content creation is very important. And so I think we're all looking at that in the same approach.
Yeah, and just to tack on to that, so even the things that OpenEXR out of the box doesn't do, we're actually building into the actual EXR itself, so that way when we create the file, all that metadata, vectors can be made into data structures, right? Yeah. So that way we're not creating any new image file, it's just new layers within the EXR spec. And the other thing that I'm really interested in just everybody's thoughts on is we're not taking into account the actual physical camera in terms of a virtual camera or virtualization of the camera, which I think is really integral in order to translate from an actual standard from the content itself into what is the display, what is the field of view, what is the actual depth of field that you need to be concerned with, what is the orientation of the display. And if you don't actually have the projection camera information or some intrinsic property of the originating source, you're not able to accurately translate between any number. I've seen all these crazy displays. How do we actually make sure that the content or the display itself knows how to do that process and transfer from whatever that content standard is into the display itself?
Can that be part of the metadata?
That's what I'm kind of hinting at. Yes.
So this is a really interesting point, and the reason why we've been not that worried about what the displays are in terms of their projections of what they do is that if we have some sort of, it doesn't have to be a mesh, if we just have some sort of function that is in either a GLSL or OpenShader language, if we have it in Octane and in the Lightfield Viewer, we can basically ray trace into any display that can be codified that way, and that should be part of the specification, the open spec specification. And inside of Octane, you can generate any sort of, you can already do baked lighting, but you can also just generate a point cloud and just shoot rays. And that's for the editing and rendering process, but in the playback process, the Lightfield Viewer or Stream should be able to support that. And that means that the devices that you're beaming to essentially just have to provide a representation in an open shader language type of system that handles that kind of projection. And if that works, then we're pretty good to go, I think. And that's kind of how we've approached trying to support every device we can think of.
So nominally, as Walt was saying, what we're looking at is an ecosystem that goes from the 3D source, either content creator or stored data, to the display.
Right.
And all the pieces that are in between, and hands something that the display can turn into a 3D frame to it. So it's all the pieces in between.
Right.
And the bandwidth has to be suitable at something, it can't be terabytes per second.
Well, it depends on where. On the production side, terabytes are much more tolerable than
terabytes per second.
Terabytes per second.
Yeah.
You notice I just said terabytes.
Yeah.
We can do 300 gigs, so we're getting close. Okay.
It's like the Moore's law, let's give 4 more years, right?
I think the key point, and the gentleman raised it earlier, is you need to standardize the center of this ecosystem, right? The displays, you want to go out to multiple displays. So you want to make sure you have an ecosystem or standardization in the middle of it that allows you to come from any type of camera source, if you will, or cameras, I should say, or light field, to a defined file format that then goes out to any type of light field, VR, stereoscopic display.
Correct.
I think that's the key.
That's true, although it normally is supposed to allow for interaction, which is almost a one-to-one rather than a broadcast. Point of view change, position change.
That's the display side that you're doing, right? So you have input from
Well,
your user.
some displays could do that and some can't. So
I was thinking the standard, maybe the standard has to deal with all 7 dimensions. Your recording device may record some reduced set of that, and your display device may be able to handle some reduced set of that, right? But the middle part has to be able to handle all those 7 dimensions.
Yes.
Yeah.
A good example is like object-oriented audio, right? And you have the renderer at the end of the device at the other side. It takes whatever it can, adapts it to the number of speakers and the volume that you have. I think we're talking about a similar situation here.
Yeah.
Tack onto that. So the interchange format we're using in order to go from the CG world to content creation, live capture is everything turns, even though we do 4D, everything is a multi-view generated image, meaning that you have 2-dimensional images. They have the tacked on camera intrinsics, extrinsics, and that way I can go to any 3D software. I can render everything out. You don't have enough view data, meaning you don't have the true 4D planoptic function for it. You have missing or some kind of a sparse array. What that really means is that you would have your depth information or some other element you can interpolate, and you can then generate whatever the display requires. So I'd advocate for everything being something that's based upon a plane in space with a multiple view and camera profile, and then obviously layered up with whatever other dimensionalities you need. And then that way it's arbitrary at that point to go between any other system.
So does OpenERX become that a starting point for that platform?
Well, I'd say yes, because I'm already doing it, so it's easy for me. But it's something that just talking at the cinema level, it's already adopted for visual effects and for post, for a lot of it, not DPX, of course. So that would be an easy way for the content creators. It's not really designed at all for streaming, however. It's not something that's designed for real-time playback because it's based upon all of this rich, very dense data. But that could be a format that goes into, right. It's just like you would create your mastered file versus what you have for JPEG 2000 DCPs. Yeah, we use those as well. Of course. Yeah, there's a lot of lossy and non-lossy. Yeah, the overhead of EXR, especially if you start loading it up with this many viewpoints, just the load times get into the bandwidth restriction. Fundamentally, you need to distill it down into presumably what's required for home distribution, which makes you have to reformat things into a 10 megabit, 50 megabit, whatever we want to target. But then at least you have that interchange of the multiple view, the associated metadata that allows you to go between the content creators and their display.
And again, if you're mentioning the common standard format, I would like to bring up the word ASUS.
Sure, yeah, I mean, that's a color component of that thing, but
having that common color space and that wide dynamic range of ASUS now opens you up to do anything you want to do on the display side, as well as being able to capture anything from any camera that you can come up with. That's the kind of thing that you're looking for in this 3D world.
which is supported in OpenEXR. So I think OpenEXR, to your point, is a very good start. I mean, we have to look at everything else, but I think it's a really good start for the production side, like you said, where you have 10,000 cores and stuff that you can put to this stuff. It starts getting easier depending upon the number of cores. But
Okay, good. Let's move on to another question. One I put up here, let me read it to you. It says, would a consortium, association, or working group be helpful to aggregate information related to streaming media of field-of-light displays and share between various SDOs and industry, and accomplish tasks to aid in the standardization process? This is very similar to the mission statement that David has defined for the VR Industry Forum. The question is, do we need another organization that has a little bit different focus, more on light field and more advanced, that ecosystem, as opposed to a more VR-focused ecosystem? Any thoughts on that?
Well, there have been successful IMs, terrible IMs. So it really depends on the motivation of the participant.
So I can speak to two things that are connect to this. I mean, one is there is OpenVR, right, which is something I think is being proposed to Kronos, but I don't know how well that'll be adopted because every VR vendor wants to have something different. Like Oculus has asynchronous time warp. It's not necessarily going to go into that open spec. But Kronos is interesting. I mean, the reason we have WebGL and even WebVR is because Kronos has helped push that. OpenGL is obviously a huge part of that. And GLTF, which is a spec that we're not contributing to, is also Kronos. So I think Kronos, for anything that is in the 3D space, especially real-time and even things going into browser-like formats is really useful. And that's separate, I guess, from compression and other pieces. So I think Kronos will continue to sort of build on these specs, and they're doing really important pieces that we know are fundamental to playing back and supporting what we want to do at a low level across every possible device. Ideally, at some point, the web browser. So maybe some of that can go to them, and then other pieces can be adopted, on the more traditional, fixed media side of things.
So if I could answer your question, I think it is needed as a very specific work group. The idea of the industry forum, and I've been connected now to 4 successful ones, starting with the MPEG industry forum, which was the last. They actually won the battle between H.264 and what was Windows Media 9. Anyway, bottom line, though, is that what the industry forum is trying to do, as I said, is to go across all those streams. It will require specialist liaisons with groups like you're suggesting here, and of course with MPEG, with JPEG, and so there's liaison is a key part of the work. But trying to glue it together is the aim of the industry forum.
Yeah, no, I think, well, I'm totally on board with your mission and what you're trying to do. It's identical. That what I'm struggling with is maybe the structure to accomplish that.
But I think a specialized group looking at specific, this light field is actually a very
within the industry forum, within the VR forum.
It doesn't have to be within the industry forum. It could be outside, but liaising with. So whether it becomes part of what you're doing, Chris, or it's somewhere else. Maybe it's inside SMPTE. I don't know, but definitely it is. Something needs to glue all the pieces together to make end-to-end ecosystem work.
Exactly.
I guess I was the same. There's somebody needs to glue it together, but I don't know if you need a separate new organization to pull that off.
And then where does it sit? How is it structured? How does it accomplish its goals?
Well, I think it's who wants it at some point, right? There are so many other standards organizations, right? Who wants to take it on, I guess, is probably the bigger question.
Could it be?
Well, the common problem with ecosystem development is almost always commercially driven. That's a big problem with developing the system. We're getting a number of companies together to work in an ecosystem. They have to be focused on something more.
Yep.
The problem with a lot of these industry forums is everybody's got their own vested interests. The ones that are successful are when everybody's focused on the same thing. Equal pain. Pretty much. Equal pain, equal gain.
Which is why we have, the VR Industry Forum, we have now set up under Rob Conan, who was the first president of the MPEG Industry Forum. He has got a work group going to define in detail what that common goals are. And if people don't have that at heart, then they don't need to be part of the forum.
You also need a good leader.
For sure.
So is it possible that this light field focused group could be a working group in the VRIF?
One of the things that also needs to be considered, and this obviously is a big picture focused group, but we're also interested in incorporating things like CAD models. Everything is computer-generated, it's all work-based. And it's not about capture, but it's about showing automobile design or architectural design, those kinds of things. And all that is student-based as well. So we need to, at least from our perspective, we certainly want that to be part of what's going into building all these standards.
To your point, so we have plugins for Revit, for AutoCAD, and all of these export in that Orbex container, GLTF with the shaders, the BRDF. So that's something that we're definitely thinking about and should be part of any of these specs. And then as far as our next steps, we want to contribute everything that we've done to JPEG Plano and basically see where that goes. Even with just that, there is the concept of within a single shot the ability to have motion. So even though for JPEG it would include the time layer. And then there could be other elements on top of that for MPEG. But I do feel like, all the work that we've been doing at least feels like it's the right fit for JPEG Plano, and I think we'll see how that develops. But hopefully we'll start playing with that next year.
Are you willing to have other people modify it?
Yeah, I mean, I think that, actually, no, that's true. No, that's, yes, yes, but
Otherwise, it's a non-starter. because
but wait a minute,
Just
though.
from listening to you, I get the sense, what I'm hearing is, do my thing, do my thing.
No, you're wrong, because the way that Orbex is built up is that it's actually using EXR, GLTF, which we didn't invent, right? Open share line, which we didn't invent. We actually just collected everything that worked practically for our product, and like, this is, everything that isn't in this bucket is because it failed. You know, there's other mesh formats that are just awful, like Collada, that we just, no way, we're not using it. Even FBX was like, we struggled with that. So when we were going to build a competitor to FBX, and then GLTF came along, and we're like, well, this is as good as what we were building. So I don't want to do any extra work, and that's one of the reasons why we're not like looking at commercializing this part of it. But there's a lot of separate things in the industry that are really good, like OpenVDB for volumes is great. So we're almost to the point where almost every one of these pieces has been figured out by somebody, and the pieces that we're adding are really small, other than just to almost validate commercially these pieces all work together, and here's 21 apps that we were able to export in this format too. And I think that's different than us building it all from scratch. We wouldn't want to do that.
It's a wrapper, I think you said, with some tweaks.
Yes, it's like, and we could even use, you can even zip it all up, but there's problems even with the zip standard as far as using newer things like LC4. We wanted to have something that its container format was a little bit more structured than zip. But, you know, that there's really, we're very close to having a lot of these pieces across the industry figured out. So for us, we are just collecting them and submitting that to the JPEG bundle, which is, you know, here's everything you need to render a scene, and most of these are already really well thought out of the standards, and these are a couple of pieces that are missing. And even for the codec work, like, we want to have a robust way of, in the spec, having OpenGL shaders or open shader language, something that allows us to build a living codec and living, transfer functions, so that we can just keep this thing, going and not be limited to a spec that changes, every 4 or 5 years. I think that already with WebGL, you've cracked that door open to being able to do so much in the browser. Taking it a little bit further, where you just have shaders that can be run for compute, for meshes and all that. It's going to allow us to really have a flexible standard that keeps evolving as the devices evolve, and they will evolve and change very quickly from this point onwards.
So I wanted to follow up on a comment you made, Walt, about having commercial support for any kind of industry forum. Clearly there's a lot of interest in MPEG and the VR forum and JPEG right now from major studios, major companies. In your opinion, if some organization was formed, would there be support from those organizations that focused on the light field ecosystem? And that's really directed to you, David, and Ariane, and you, Walt.
The problem I'm having is that there's the initial phase of this is one where light fields are still going to be a thing in the future. It's
for sure.
So what we are concerned about is what we can do to help get the plane off the runway, rather than what it can do at 10,000 feet. So that's why, even though it could be part of the VR industry forum, and funds are coming in, but companies, all those 27 founded companies are all putting money into this thing. We believe that there are higher priorities in those work packages first. But I would imagine that pretty soon we'd need to get to this. If it wasn't already being done by an organization such as, this one, SMPTE, whatever it's called, FOLD. Yeah.
Yeah, okay.
So I'd say that I'm finding this interesting because outside of a lot of the companies that are on this panel, so looking at the light fields from Otoy and then Fraunhofer, Lytro, and there's maybe another 5 or 6, arguably, companies that are actually generating true light field data. So I'm eliminating the majority of VR at this point, because that's not actually light field data as much as everybody keeps talking about it.
Yep.
I'm a little biased, of course. The commercial application of this, it's going to be very difficult until you see either a display that everybody is pushing towards that is true light field, and there are a handful of companies, obviously, mostly on this panel and a couple of other big guys, that are working towards that. But right now, as VR stands and as the limited number of AR devices out there, there's no light field, right? So I think it's I wonder if we're trying to address something that is going to be modified by the company that eventually will win that race. I don't know who or when that is from the display standpoint, the ultimate end consumer standpoint. And that will ultimately drive what happens. And I think a good example, and Dolby does this fantastically when they have their audio or their video systems, they have the end-to-end ecosystem, and that drives a lot of the format that ultimately will dominate and win. I think that's what's needed right now. So it's a little difficult to...
And that champion has not risen.
There's a lot of them, they're just not...
Visible yet.
Yeah, correct.
Okay. Well, the other point is that because we're looking at a Phase 2 SBIR award for this, there is some money to be able to have staff to do some of these tasks to help move the agenda forward. So it behooves us to try and find a home for this activity.
Earlier, I made a statement that the only light field displays being developed were US DoD, and that's not correct. The Japanese and the Chinese and the Europeans are also have some efforts for developing light field displays. So I think it's only in the U.S. I believe it's the DoD is pushing light field displays.
Actually,
Today, that Dolby now has a light field
well,
display.
and then there's Ostendo in the audience also has
Yeah,
one.
and then...
Ostendo.
Yeah.
Yeah, I mean, even other company, without going to names, Florida, blah, blah, blah. I mean, I mean, yeah, okay, yeah. Figured anybody else wants to bring them up. I mean, there's a lot of companies that are not, I mean, you have Leia, I don't think they're DoD at all. They're doing a lot of diffractive optics and light field displays. So, you get, yeah. No. It's amazing how many companies are actually trying to do this and then tackle the same challenge and the same problem, but they haven't been commercially massively successful. I'm not saying they're not successful. I'm just trying to be clear about what I'm saying. It's just you haven't seen one in every home or in a domination number of homes. Even the VR headsets, you're still not seeing market penetration on these.
Sure. There's no doubt it's early days.
Right.
So one of the, it's unfortunate the Note 7 blew up because, Samsung was going to invest the billions of dollars into that, 11K phone display, which would have 2,000 dpi. The only reason they were going to do that was so they could do what Leia is doing only at a much higher level, and you'd have an awesome starting point for true light field display. So hopefully they'll still get back to that, and that to me is really going to be exciting. I mean, when Samsung produces, displays, that is for the mass market. So I feel like that would be a really interesting inflection point.
Yeah, but then Samsung will probably own the standard, so.
Yeah.
This question of a Phase 2 project and money, we have ample evidence that if some sponsoring organization locks would-be interoperable participants in a room with the rough agenda of nobody leaves the room until this stuff interoperates, or at least we have a list of what didn't work. We have proof that works. That's essentially what brought IMF to success. Yes, the due diligence process was necessary, but it was the leader, the fact that everybody trusts Jerry Pierce, and he started organizing these quarterly meetings where at the Plug Fest, nobody leaves unless it interoperates and or at least we write down what's still broken, ostensibly with the goal of fixing the parts of the documents that weren't clear enough.
Mm-hmm.
But the informal people running into the hallway arguing with each other about I have to work around your bug was an important part of the human process.
Sure.
And the sponsorship was the person who hosted the room, which was often Netflix.
Okay.
There's 3 drivers to success. Knocking cigarettes away. Don't forget food.
Okay. I'm kind of running out of steam, running out of questions. I think we've beat this pretty well to the ground, don't you think?
Yeah.
Okay. Let's thank all of our speakers.